All right, so that's a matrix. It's a rectangular shape with entries that are filled in all of these. Many of those entries might be 0. That's okay. What can you do with a matrix? Well, first off, let's look at the basic idea of adding and subtracting matrices. You can see here that the first example I've given is adding the column vector AB and the column vector CD, and that gives you also a column vector where the first entry is A plus C and the second entry is B plus D, just like we did when we added matrices. So what we're doing here is we're going to generalize the addition of matrices, or sorry, vectors, just like we did when we added vectors, and we're going to generalize how we add from vectors to matrices. Now, the second example here on the screen, there are 2 matrices, each of which is 3 rows and 2 columns, and there's a minus sign between the 2 of them. So we're taking the first matrix and subtracting the second. You can see in the upper left of the first one that there's a 1, and the upper left of the second one there's also a 1. So 1 minus 1 is 0. So in the result, the entry in the upper left is 0. The entry in the upper right, which would be our element first row, second column, so 1, 2. The first matrix in the equation has the entry x, and the second one has 4, so what we have is x minus 4. Likewise, in the second row, the first entry on the left is cosine theta, and the one on the right is 2, so it's the result is cosine theta minus 2. And then 0 minus 5, so you get minus 5, and then a minus 3, so you get a minus 3, and then b minus 6, so you get b minus 6. Clear enough, I hope. It's pretty easy. You go element by element to do addition or subtraction. Importantly, people get this wrong. They make the mistake of adding or subtracting matrices that are different sizes. You can't do that. If I give you a problem that has something like that on it, just cross it out and say, Sensei, you can't do that. Now, here's an example. We've got the 1, 2, 1, the 2 row 1 matrix, 2 row 1 column vector, and we're trying to subtract the 3 row 2 column matrix. You can't do that. It's forbidden. So just get it out of your head. Don't let things like that happen on your paper. All right, just to be a little bit more formal here on a couple of additional topics. First off, so here you can see I've written 2 matrices, the matrix A and the matrix B, both of which have corresponding entries. At the bottom of the slide, you'll see that addition is written a little more formally there. So A plus B equals, and then for every entry, so the entry in the upper left is A11 plus B11, and the entry all the way in the bottom right is AMN plus BMN. Okay. One other thing that we should formalize is 2 matrices are equal when A sub ij equals B sub ij for every I and j in this. So I can be any number from 1 to m, it's your row, and j can be any number 1 to n, which is the number of columns that you've got. So every single entry in the matrices has to be equal in order for 2 matrices to be equal. Again, this means they also have to be the same size. So if I give you 2 matrices and ask if they are equal, and the 2 that I give you aren't the same size, tell me, can't do that. We multiplied a vector times a scalar. So here we've got the scalar A. You can likewise multiply a scalar times a matrix. And what happens there is you pull the scalar inside and you multiply all of the elements. So if the upper left entry of capital A is little a11, then after we multiply by the scalar k, then the entry in the upper left is going to be k a11. and the next one will be K, A1, 2, and so on through the entire matrix. One more, addition is associative. So if I give you A plus B plus C, you can group that as either A plus B first, or you can group B plus C first. So just like with adding regular numbers or adding matrices, as long as the matrices are the same size, then you can add them, and it doesn't matter what order you add them in.
Everyone, stay safe, and I'll see you in the next video.